Section 4.6, Formalizing Relations and Functions. Example, identifying functions using mapping diagrams. Express the relation 6, -1, 5, 0, 2, -4, and 1, 0 as a table, as a graph, and as a mapping diagram. For this, we're only going to focus in on, we're going to look at just the mapping diagram piece. So the first thing you want to do is identify the domain, and the domain is the list of values that represent your input or your independent variables. So in this case, it's 6, 5, 2, and 1. Your range, on the other hand, would be your outputs. So in this case, -1, 0, -4, and then 0 repeats, so we don't have to write it twice. All right, so we've got our x values for domain, y values for range. And now a mapping diagram is where you list these. And I like to start off by using circles. I put 2 circles, part like this, and I list the domain in the left circle. So 6, 5, 2, 1. And the range in the right circle, -1, 0, -4. The reason they call it a mapping diagram is now we draw lines between the domain and the range values, or the input that goes to the output. So in this case, we know 6 goes to -1, 5 goes to 0, 2 goes to -4, and then 1 goes to 0. And we can tell that this is a function because each of our input values goes to an output value, and each input value is only used once. So each of the values of the domain was used once, and they each went to some output value. In the next example, give the domain and range of the relation and as a mapping diagram. Tell whether the relation is a function. So this time we're going to create our mapping diagram. We'll have the domain here. And we know the domain is, in this case, 3, 5, 4, and then 3 repeats, so we don't need to write it again. Then we've got range, which is -2, -1, 0, and 1. All right, so we create our mapping diagram. So I've got my ovals or circles. They're more oval than circle. So we've got 3, 5, and 4, -2, -1, 0, and 1. And so in this case, 3 goes to -2, 5 goes to -1, 4 goes to 0, and then 3 also goes to 1. And right now, I already know that this is not a function because the value for 3 goes to 2 different outputs. So this is not a function. So 3 has 2 different outputs. All right, again, we want to express the relation -2, 5, -1, 4, 1, 3, and 2, 4 as a mapping diagram and determine if it is a function. So let's just go ahead and list out the domain and range again. So -2, -1, 1, and 2 is our domain. Our range, or our y values, is 5, 4, 3, and then 4 repeats, so we don't have to list it again. All right, so we create our mapping diagram. So we've got our 2 ovals. There we go. -2, -1, 1, and 2, 5, 4, and 3. And so now we draw lines between the inputs and their outputs, or the domain and the range. So -2 goes with 5, -1 goes with 4, 1 goes with 3, and then 2 goes with 4. So once again, each of our input values, or our domain values, is used only once. So yes, this is a function. each is used once, and they each go to one output. All right, so now we're talking about the vertical line test. And the vertical line test states if you draw a vertical line and it passes through more than 1 point on the graph, then the graph is not a function. So if you have a graph of what you suspect to be a function, if anywhere on that graph you can draw a line that's going to cross through the graph more than once, then it's not a function. So what they want us to do here is they want us to plot these points and see if this relation is a function. So we'll start plotting them on our grid. So negative 4, 2. Negative 3, 1. Negative 3, negative 1. Zero, negative 2. And negative 4, negative 1. And then 1, 2. And so now we look and see if this would satisfy the vertical line test. And so I can draw a line anywhere. But I notice in one particular spot, if I were to draw a vertical line straight down, I would intersect two of my points. And based on the vertical line test, if I cross the graph more than once, it is not a function. So in this case, these points do not represent a function. It fails the vertical line test. All right, in the next example, they're asking us, is this graph a function? Well, if you look at the graph, no matter where we were to draw a vertical line, and these aren't the best vertical lines, but anywhere we draw a vertical line, we're only crossing the graph once. So this is definitely a function. All right, and the next one, error analysis. A student drew the dashed line on the graph shown and concluded that the graph represented a function. Is this student correct? All right, so this is their graph line. This is where they chose to draw their line. And yeah, their line only crosses the graph once. But the problem here is, had they chosen to draw their line here, they would see that their graph intersects their line 3 times. So that's their mistake. They didn't draw their line in a good spot. And so their mistake, in this case we know the student is not correct. And this student should also know that this is not a function, because it fails the vertical line test. It fails the vertical line test. Right, so the student is not correct. This is not a function, and it fails the vertical line test. Okay, so this is a refresher on function notation, which we talked about in 4.5. Take a minute and read this to yourself, just to get yourself reacclimated with the idea of function notation. All right, so now we're talking about evaluating functions. So in the first one, the function w of x equals 250x represents the number of words w of x you can read in x minutes. How many words can you read in 8 minutes? So in this problem, they're asking us to plug in 8 for w. So we're going to get w of 8, or in this case, the words you can type in 8 minutes equals 250 times 8. So in this case, you can in this case, you can type in 8 minutes right around 2,000 words. The next one, the function t of x equals 65x represents the number of words Rachel can type in x minutes. How many words can she type in 7 minutes? All right, so we're going to evaluate for how many words Rachel can type in 7 minutes. In the previous problem, we figured out how many words you can read in 8 minutes. I said type. That was my mistake. It's how many words you can read in 8 minutes. This time we're looking at how many words you can type in 7 minutes. So that means we're plugging in 7. So t of 7 equals 65 times 7. And in this case, in 7 minutes, you, or in this case, Rachel, can type 455 words. Now we're talking about evaluating the function for the given input values in order to determine the range. And remember, the range is the outputs, or in this case, our dependent variable values. So what they provided us with is they gave us the domain they want us to use, 1, 2, 3, and 4. And for each of those values, we're going to plug them into this function and see what we get out in return. That way we can figure out our range. So we're just plugging them in as we go. So in this case, we start with 1. So in this case, we get 3 times 1 plus 2 should give us 5. Then we move on to 2, and we plug in 2 for x. So we've got 3 times 2 is 6, plus 2 is 8. And so on, we go plug in 3 for x. We get 3 times 3 is 9, plus 2 is 11. And then last but not least, we plug in 4. You've got 3 times 4 is 12, plus 2 gives us 14. So in this case, our range can be represented by the values 5, 8, 11, and 14. We want to do the same thing in this problem. This time they give us the function h of c equals 2c minus 1, and we want to find h of c, or in this case the range of values, given the domain of c equals -3, -1, 1, and 3. So go ahead and plug those 4 in and see what you get. Unpause the video when you're ready to check your answer. So in this case, once you've plugged in -3, -1, 1, and 3 for your x values, you should get -7, -3, 1, and 5 for your c values, not your x values. So your independent variable is c this time. So you're plugging those in, and these are your outputs. So h of c should equal -7, -3, 1, and 5. So that means your range in this case is -7, -3, 1, and 5, given your domain of -3, -1, 1, and 3. Finding the reasonable domain and range of a function. Joe has enough money to buy 1, 2, or 3 DVDs at $15 each, if he buys any at all. Write a function to describe the situation. Find the reasonable domain and range of the function. If Joe buys X DVDs, he will spend f of x equals $15. So this is our function. And I know it said write one, but I'll give you the equation here. F of x equals 15x. All right, so that means the x in this case is your input values, where f of x would be your output. So you have to think about what's reasonable for the number to plug in for x. So what are reasonable values for your domain in this case? Well, it says here he has enough to buy 1, 2, or 3 DVDs if he buys any at all. So that means he could buy 0, 1, 2, or 3 DVDs. Then to figure out your reasonable range for this particular function, you have to think about, well, what values would we get back if we used any one of these values for our domain? So if we plugged in 0 into this function, 15 times 0 is just 0. If we plugged in 1 times 15 is 15, 2 times 15 is 30, and 3 times 15 is 45. So if this is considered our reasonable domain, this would be our reasonable range. These would be the values we get back for plugging in 1 or 0, 1, 2, or 3.